Thank you, Brenda Work, for sponsoring this video. Okay, as we all know, this right here is our usual definition for a regular factorial, but have you guys ever thought about what if the factorial gets superpower? And also, what if the factorial gets hyper? Oh well, in this video, let me show you guys the definitions for these two factorials and also show you guys a really cool connection between all these three factorials. So check this out. Here we go. For the super factorial, in fact, we have two definitions for that. Let me demonstrate the first definition right here, and at the end of the video, I'll show you guys another definition, right? So, notation for this is that we put down n with a dollar sign next to it. Yeah, dollar sign. Cool, huh? Alright, here we go. What we do is we start with n factorial, and then we multiply by n minus 1 factorial, and then we multiply by n minus 2 factorial, and then dot dot dot, keep on going, until we have the 3 factorial times 2 factorial, and finally we have that 1 factorial, right? So again, this is just one of the definitions, and I will show you guys another definition, and this another person is Ploff. Yeah, by Salon and Prof. And the other definition is by Pickover. That's at the end. And the interesting thing is that both of the definitions were published in 1995. So yeah. Anyway, for the superfactorial, we only have one definition, and the notation is we use h of n like this. What we do is we start with n and raise to the nth power. Yes, this is big enough already, but we will have more. What we do next is we have n minus 1 raised to the n minus 1 power, and then we multiply by n minus 2 raised to the n minus 2 power, and so on, so on, so on. 3 to the third power, 2 to the second power, 1 to the first power, like this. So this right here is the hyperfactorial. And all this right here, they're just for positive whole number n, right? And have you guys seen any of this? If you guys have, let me know. Comment down below, right? All right, and the truth is, when you have 0 factorial, that's 1. When you have 0 super factorial, that's also 1. And when you have 0 hyperfactorial, that's also equal to 1, right? That's pretty cool. Now, here we go. I wanted to show you what if we multiply the superfactorial and the hyperfactorial in this video right here, right? So here we go. Let me start with n with the dollar sign for the superfactorial, and then I will multiply by h of n, which is the superfactorial. So here we go. For the superfactorial, notice how we have the n factorial right here. So I will use this definition right here first. What we do is we just have n times n minus 1 times n minus 2 times dot 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 times 3 to 1. So this guy is for the first n factorial. Don't forget though, we still have to have the n minus 1 factorial. So what we have to do is, I will have to multiply, right? So it's following right here, n minus 1 factorial that. So that means n minus 1 times n minus 2 times dot dot dot, and then we have the 3 to 1 like this. And we still have to continue with the n minus 2 factorial. So you see, we'll just multiply by n minus 2, dot dot dot, 3 to 1 like this. And of course, we have the 3 factorials, 2 factorial, and also the 1 factorial. So you just see a lot of dots and a lot of numbers. Whew. So it's like a little triangle like this, right? So that's pretty cool. Now, let's look at h of n, namely the hyperfactorial. First thing first, we start with n to the n. That means what? N times n times n, n of them, right? So what I'm going to do is I will put down this right here. We will have to do n times n times n times dot dot dot. So we have put down like this, dot dot dot, like this, okay? And we have n of this right here. Next, we have n minus 1 to the n minus 1. Well, we can fill in the gaps right here. So we multiply by n minus 1, and we have to do it n minus 1 times. So this is the first, and then we have the next one, n minus 1, and then dot dot dot, and then we have the n minus 1 like this. Similarly, we have the n minus 2, so it's just, you see the pattern, huh? Hopefully. And then we have all this n minus 2, and you see we can actually create a very nice rectangle. So in the end, what do we see? We have how many n's? This is total of n plus 1 n's, because remember this is n n's, and we have one more, so it's n plus 1 n's. So this right here is n to the n plus 1. Similarly, from here to here is also to the n plus 1 power, so we multiply by n minus 1 for the base raised to the n plus 1 power, and likewise for this, which is n minus 2 times raised to the n plus 1 power, and so on, so on, so on. And we have 3 to the n minus 1 power, n plus 1 power, and then 2 n plus 1 power, and 1 to the n plus 1 power, and all that. Everybody has the same power, namely n plus 1. So altogether, we can just put everything inside. And if you see everything right here, if you put it inside your for parentheses, this right here is nicely equal to just n factorial. Yes, so you have n factorial in the parentheses. So if you look at all the red parts right here, right, all the red parts together, they will give you the n factorial. And don't forget, you raise that to the n plus 1's power. So as you can see, when you multiply the superfactorial and the hyperfactorial, you end up with n factorial in your parentheses, and then you raise that to the n plus 1 power like this, right? I'm sorry, just want to make sure you guys can see, okay. Hey, do you want to learn more math? If so, then check out Brilliant.work. This right here is a math and science website that focuses on problem solving. As you can see, not only they have daily challenges for you guys, but also they have over 50 interactive courses, including probability, math contests, geometry, and also differential equation. And all of their courses are carefully and interestingly designed, so you guys won't be bored. One thing I like about Brilliant is that they really walk you through each and every concept. So as you can see, this right here is about the misconceptions in probability, and this is the famous Monty Hall question. And here we have the Russian roulette question, and here is the boy and girl paradox. And for the people who have not done probability before, this is a great way for you to really start learning. And if you'd like to give Brilliant a try, you can use the link in the description, brilliant.work/blackprintrepen. This way you can get a 20% off discount to the annual premium subscription so that you can get the access to all of their courses. So here is just the other version of the superfactorial, and as I said earlier, this is done by Pickover and in the same year, 1995. So here we go. In fact, we have the same notation for that as well. So we have n with a dollar sign. But in this case, this is going to be even crazier than any of that. So check this out. When we have this version of the superfactorial, what we do is we do n factorial, and then we do the up arrow, 2 of them. So this means the titration, okay? And then n factorial, like this. So what exactly do we mean? Well, here is your base, so you have n factorial to start with. And this right here, it's the height. And the double up arrow means you just build out the power. So you have n factorial raised to the n factorial raised to the n factorial dot 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 raised to the n factorial power like this. Well, what's the height? Again, the height is n factorial. So I'll just say the height is n factorial. And this is just crazy, okay? So let me give you guys a quick example so you guys can see. Let's see 3 with a dollar sign like this. $3 is really small, but $3 sign. Man, I don't know how to compute this anyway. Check this out. $3 sign means we have to do 3 factorial and then double up arrow. So I'll just put down up like this and then 3 factorial. Okay? As we all know, 3 factorial is just 3 times 2 times 1, which is 6. So this means 6 double up arrows, and we have another 6 right here. Well, this 6 means we have the base, and this 6 we just have to do 6 to the 6 to the 6 to the 6 to the 6. Let's see, 1, 2, 3, 4, 5, and then one more 6 like that for the power. So this right here, you see that the height is equal to 6. I don't even know what 6 to a 6 power is, so don't ask me like what's 6 to a 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 6 power, right? So this is just crazy. And for the people who like the big numbers, yeah, you definitely should look up the superfactorial, the hyperfactorial, and also this version of the superfactorial. The dollar sign matters. And as always, that's it.